Okay, students, if you hear me, just good afternoon again, and we can start our lesson for today. So let me share my screen. Today we will discuss about second type of the machine is the turning machine and turning operation mainly just yesterday we discussed about milling machine and today we will study the turning and take the information deep analysis on the difference between the turning and the milling machine, so you will start to understand the how the operation of the turning is generated. So after the completing of this lecture, you will able to answer the following questions. So firstly, you will able to give the what is the in general the turning operation is the, and we will study the type of the turning. So then we will study the components of the lathe. It is the lathe is called is a lathe is the machine for the turning operation. It is called lathe machine, or you can call it as a turning machine, so it is the same. Then we will talk about the tools available for the turning operation, and as well as we analyze it in the milling machine, we analyze the cutting condition in the turning operation, as well as we will study the cutting, how to calculate the rotational speed, cutting speed, and so on, feed rate, for example. So just a moment. Okay, so let's go on. So yesterday, just okay. Yesterday we have seen the milling operation is the. Let's analyze the between the difference between the milling and the turning operation. So yesterday we analyzed the milling as a prismatic workpiece. Prismatic workpiece is the fixed on the table. On the table is fixed, and the table can move horizontally and the transverse direction toward the column. And we have the tool in this case, let's assume the uh, face milling. It is the axis of the tool is the perpendicular to the surface being machined. So we have seen this kind of milling operation. So it rotates and removes material from the surface. So in this case, the tool rotates and the table moves longitudinal and transverse direction. And the important thing was this workpiece is fixed on the table. So this is what we seen yesterday for the milling operation. In the case of the turning operation, mostly, not the mostly, always we will work with the cylindrical parts. So you see it is the cylindrical part. It is fixed on the spindle. So spindle rotates, and as well as this cylindrical part also rotates with the spindle. So it rotates. So then we have single point tool, like it is the form will be mostly like this. So it is the has a holder here and removes material from the surface of the from the both surface of the workpiece. Just a moment. So this is the what is the called the turning machine. In this case, tool moves here in the feed rate in this direction or in the downward direction to remove this one. So main difference, sorry, main difference between the between Walaikum Assalam. Main difference between the milling operation and turning operation is that in the milling workpiece is fixed, and the turning in the turning operation in the turning operation the workpiece is the rotating. So it is the main difference. Also in the milling machine we will basically work with the prismatic rectangular elements workpieces. In the turning operation we will make the operation with the cylindrical elements. Okay, is it clear? Okay, yes, good. So also, what is the important between the turning and the milling operation is that we have seen in the turning and the milling operation, it is the value, is the number of the Z, is the number of the T's of the tool. So it could be range from the 2, 4, and 6, 8, 10, and so on. It is the number of the T's in the milling operation. In the case of the turning operation, since it has only the single contact point in order to remove the material, so Z in the turning operation is always equal to the 1. Okay, it is important to calculate the cutting condition in the turning operation. This is always 1 because we have only contact point here. That's why we will take, because why I am telling this one, because in the exercise that will be not be given in the turning operation, so you have to select a z as equal to the 1 when the calculating the cutting parameters of the turning operation. So it is clear. So here you see the what is I draw here. So tool is rotating, workpiece is fixed, and it removes material from the surface, prismatic element of from the surface. So in the case of here we have cylindrical element rotates, it is fixed on the spindle. So here you see the single point tool is removes material. So you see here it is the this is the initial. Uh, yes, please. What? Sorry, sorry, just okay. I will explain again. Okay, from the beginning. Sorry. So okay, let's start. So it is the we will. Can you hear me now? Okay. Yesterday we saw the milling operation. It is the first step of the CNC machine. So today we will talk about the turning operation. So this is the content for the today. So after the completing of this lecture, so you can able to answer the following question, and this is the you will define the what is the turning operation is that, and we will define the difference between the turning and the milling operation. Also we will talk about the lathe and its component. Lathe is the machine for the turning operation. It is the called a lathe. So we can call it also as a turning machine. Then we will talk about the tools available for the turning operation, and as well as we discussed it in the milling operation, we talk about the cutting condition in the turning operation, how to calculate the cutting parameters of the turning operation. So let's discuss difference between the turning and the milling operation. So as we have seen yesterday, as a milling operation we have the prismatic workpiece. Okay, prismatic workpiece, and it is the fixed on the table, so that table can move in the x direction and the y direction. The workpiece is the fixed, and we have tool. Tool is the tool, and let's assume it is the case of the face milling, and the axis is the perpendicular to the surface being machined. So axis in the face milling was perpendicular. So this tool rotates around its axis and removes material from the surface, making some shapes and so on. It makes some drills or so on. So main things in the case is for workpiece is fixed. In the case of the turning operation, we will work only with the cylindrical elements here. Cylindrical elements. It is fixed on the spindle. So spindle rotates around its axis. Since spindle rotates, workpiece also rotates. So, so it is the workpiece also rotates. Then we have single point tool. It is like this. Single point tool removes material from the, since it rotates, it removes from the material layer by layer, removes material from the surface of the cylindrical element in order to obtain the final shape. So main difference between the milling and turning operation is the workpiece is the prismatic and it is fixed on the table. In the turning operation, our the workpiece is the cylindrical and it rotates with the help of the spindle. So and the tool is moves in the this direction, can move and move in the this direction. It is the x direction and it is the z direction, and this is the how the difference between the milling and the turning operation. So it is clear the difference between the milling and turning because it is important. Okay, good. So also what I would like to highlight is that uh, we have seen in the milling operation z value. It was the number of the teeth of the our the cutter tool. So it was the range from the 2, 4, and so on, 6, 8, 10, and so on. It is the for the milling operation. In the case of the turning operation, since we have the single point tool here, just removes the material, that value is equal to the always the 1. Okay, it is the important. Just a moment. It is the important because when you calculate, for example, the feed rate for the turning operation, the F value, it is the when you calculate Z, you will take 1. Here there was F and N. So this is the important for the turning operation, okay? Because it is not given, it will not given in the condition of the problem. So you have to take by yourself Z equal to the 1 for the turning operation. So this is the how the difference between all the turning and milling operation. You see here a cylindrical element. Here you see the in the this is the overstock, which is this is the small circle, small cylinder is the final element. So let's see the video about the turning in order to get more idea, more understanding about the turning operation. You see here, this is the spindle. This is the workpiece. It's rotating, and the tool, single point tool, is removing material. Here is just a drilling operation, making the drilling. Now single point tool is removing outer here the outer diameter of the workpiece. You see this is reducing the value. So I think it's clear that we can go on. Okay, let's little bit also the recall what was the uh, milling operation was. In the milling operation, milling operation, you see the tool is the moving and the workpiece is the fixed. In this case, only the table is the moving, and we will work only on the prismatic element in the case of the milling operation. This was the face milling, since axis is the perpendicular to the surface of the workpiece. So this is the how is the main difference between the turning and milling operation. Let's go on. If everything is clear, so let's talk about the types of the turning operation. So in general, since if we have such element, we will see with the case with the case study, with the real case study. So we have to obtain this element. It is the final element. Here we have the threads and so on, and in general there is 6 number of operations in the turning machine. So you see here the step by step, all everything is demonstrated here. First operation is the facing operation, and the second operation is the roughing and finishing, and here you will make here facing operation will be performed here. We will see with the animation, okay. And the third operation is the grooving, and the fourth operation is the you can make obtain some threads on the surface of the cylinder. You see here the thread. And the fifth operation is the boring. Operation is to enlarge the existing holes. Okay, here enlarge and improve the surface accuracy of the existing holes. And the last one is the cut off. It means that you will cut your element from this side, from the spindle. So your part will be ready. So you will be cut off the part from the remaining the stock. Okay, this is the main operations for the turning system. So let's see all of them step by step. So this is the element that is this is the CAD model of that element. You see, this is the final element. You see here the final obtained element, and this is our stock, our stock, the cylindrical element. So in the by the turning operation, we have to obtain this final element. So this is the how to see with the CAD model in the NX. So first operation is the facing. In the facing, you see workpiece the fixed, here the spindle. So in the first facing operation, the work is the tool starts its moving from this position, and will start to remove material. Here you see some facing operation start from here and goes to the until the mid of the axis, so and goes to the this position. In this case, you will cut face from the workpiece. Uh, this is the facing operation. So this is the animation of the facing. So let's see it. Just a moment. It should download it. Just a moment. So facing operation is always the first operation for the turning. Just to remove some slight material from the surface. That is the surface of the workpiece. Just a moment. It should download the video. Okay. Okay, it is the, you see It is the removing just from this side of the element surface. It is the removing not just one layer, several layers, small layers. It is in a millimeter. So step by step removing in order to remove the unnecessary part of the workpiece. You see, it starts from the edge and goes until the center of the our cylinder. So in this case, it removes from the both side of the cylinder. This is the facing operation. It is the always performs as a first operation for the turning operation. So this is the animation made by in the NX. So after the facing operation, next operation is the roughing and the finishing operation. Firstly, roughing is performed. You see, after making the finishing facing operation on this side, you see that the final element is remained here, and the roughing operation is to remove the material from this side of the workpiece. So it starts from this side and takes the layers, and you will define the how many layers to do with the workpiece. So then it finally goes to the initial condition of the tool change position. So this is the roughing operation. In the roughing operation, you will slightly remain some material on the surface of the workpiece for the finishing operation. So with the roughing operation, you will not get high quality. So that's why after the roughing operation, you have to perform the finishing operation. So let's see the animation of the roughing. It is the removing the material. It is with the layers, not in just in one run, but you have to perform the several runs in order to accrue the security of the tool, because while it is the machining, it can be the hit up the tool, also the workpiece, so it damages the tools when it hit up. So in addition, there are used some cooling systems in order to cool down the workpiece. You see, it is the uh, finish it. Somehow it remains some layer of the material after the roughing. So you see, some material is removed still. So it's some material will removed around some few millimeters for the finishing operation. After roughing, you have to perform the finishing operation. So I will show here here you see, after roughing operation, you remove here this parts, and here you see, if I will zoom here, you see some layer of the material is removed here. It is the groove for the grooving, and here it's a layer of the material is remained for the finishing operation, a very thin layer of the material. Is it clear? Is everything clear? Okay, good. So then next step is here it's a finishing operation. So the same in the finishing operation, but you will use the different tool. With we will see the type of the tools. You will use this kind of tools for the finishing operation with the high accuracy. So you see, small layer is removed by the finishing operation in order to get higher surface accuracy. So it is the initial position and final position of the tool. Just you can make one layer of the movement. So here I will download it. You see the final shape here is obtained already with the finishing operation. I just used one layer for the finishing, and while you're the programming, you can use the several layers. So the final shape is obtained almost. Now we have to do the other operations in order to obtain our element. So next is the making the threading. Is the you see here in this reading, we will use the special tool. We will see also special tool for the making the threading on the surface of this element. So this is the animation for the threading, but unfortunately the program is not able to demonstrate the threads. So here you see the tool for the threading. That there is no unfortunately holder. I did not activate the holder for the thread. So it is making the threading operation, but it is program don't demonstrate it. So next operation is making the drilling operation. So to obtain that, it is simple, the drilling operation, just we have seen in the video, to drill the hole on this z axis of the workpiece. So what I said, I mean in general, in the turning operation, you can face always around the 7 and 6 operations. So you see, it is the making I think it's not the drilling, but just the spot drilling to make the hole before the drilling operation. So this is okay. Let me. This was and sorry. Do you have question? Yes. Drilling, you will make the just when you have the surface there. So just I will explain with that. Okay. Okay, for example, the if this is the side view of the cylinder, okay, and with the drilling you will make hole here, okay, for example, hole with the drilling, okay, you will make hole. With the boring, you will increase the surface and the diameter of the hole, okay. uh, for the existing hole, for example, you increase the here diameter and the surface finish of the hole, okay. With the drilling, you en, 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 enlarge the size of the hole, okay, the diameter. Mhm. Just a moment, someone is asking, but I couldn't admit him. Okay. So this is what is the drilling. Before we saw the spot drilling, just to make some points in order to obtain the accurate drilling operation. So this is the drilling exactly. Just a moment, okay. You see, it is the obtain the hole here. So this is the what is we discussed. It's the boring. You see, you have the hole here, with the boring you will this what I said, you can enlarge the size of the hole. It is not large, but slightly enlarge the size of the hole, and with the high accuracy. Okay. So next is the groove. It's not just a moment. It should be also the, I missed the grooving operation maybe. Just a moment. Okay, let's go on. This is the last step. It's the cutoff. You mean if you assume that we say that we have here the our the part is to fix it to the spindle. So in order to obtain our the final part, we have to cut our the workpiece from the spindle. So in order to get the final element. So this is the cutoff operation. So you see here the special tool is used with the long distance, so in order to able to cut our the workpiece from the overstock. So I think this is, or no, maybe let's see it. Maybe it is growing. So this is our overstock, and it will cut our the. So you have to be careful while the selecting tool for the cutoff, since that it should not be it should be enough long in order to cut our. So it is the cut. You see, our the final element is ready, and here what I can show you is the whole the steps what we have done so far. So for the obtaining the this element, so let's wait to download it. So this is the first, is the facing operation. Always the first operation for the turning. Sorry, it is a little bit slow. I don't know why. If you want, you can skip this video, because all steps we have discussed. I think that is everything clear. The steps of the turning operation. All. Please. Aylanadi, aylanadi. Tushuntirdim-ku aylanishini. Videoni ham ko'rdingizmi? Polniy polniy 360 ta oladi, yarmigacha borsa. Da, yarmigacha borsa 360, yarmigacha boryapti, 360 oladi o'shanda. Aylanganini evaziga edi. Okay, let's skip because it is too slow, and I stopped it. So now second section is the about we'll talk about the turning machine. So turning machine is also good called lathe. You can call it as a lathe or turning machine. It does not matter. Also, so this is the main components for the turning machine. So first one is just a sheet metal here. In the sheet metal, it serves the operator from the, since here we have the chip removal, it serves the operator from the chip removal, and collects collect the chips, that is the removed metal chips, that is the removed from the surface of the cylindrical element. It is the just the collection point here, our the chips. So small the chips. Door is here. It's for the safety point of view. It is the closes, the slides and closes. So while the operator works, it should be closed. So it is the for the safety point of view. It's just two components. So the third one is which I call it before, this is spindle. So the spindle that holds the workpiece, that is the rotates, helps to rotate the workpiece. So this is the spindle. So then is the force is the turret. It is the for the holding of the tools. So it is the, we can call it the magazines of the tools. So in the turning machine we will use the several tools. So it holds the several tools. We will see it also. And the final is the control unit. So it is the what we call it in the previous, in the first lesson, is the machine control unit. So you can control the machine. So turning machine, here you see here the keywords. Here it is the emergency stops and so on. There is several buttons for the control of the turning machine. Also here you have the connection with the USB in order to upload your program to the machine control unit in order to control the turning machine. So this is the main components of the turning operation. So let's talk. Main component is the spindle, which I said that it is the holds the here the workpiece with the help of the jaws. So and here we have the element of the chunk. So this is the components of the spindle. So it rotates here with the jaws, that is the fixes, or the cylindrical tool is the cylindrical workpiece here. So and the tool changer, or we can call it as a torrent. So here you see there is places for the tools, and several tools you see here for the turning operation. So drilling tool, here also drilling. I think this is the for the threading, and this is, you see, for the grooving, or you can use it for the cutoff. This is just for the facing and the rough finishing and rough operation. You can use this tool as a roughing and finishing operation. So this rotates. So according to the program, this tool changer changes the tool and operates on the surface of the workpiece. So as we have seen, there is several steps of the turning operation, starting from the facing, roughing, finishing. So step by step, the machine changes tool automatically for the specific machining operation. So it is automatically changed. So there is also some old turning machine that could be changed with the manually. So with the advanced turning machine, so tools change it in automatically. So this is the how is the tool changer is the operating. Is it clear, this one? Okay. 27. This one, you mean? Yes. When you making the machining operation, when the tool cutter contacts to the surface of the workpiece, it removes materials, small materials, so reduces. So it is the excess of the small metals from the surface of the workpiece. So if it's clear, so we can continue. So now let's talk about the tools. We have in animation almost have seen some tools available for the operation. Now let's talk about some standards for the tools. So tools that you see in the turning, we will use the single point tools. It is the called inserts. So with the carbide insert. So material is the carbide insert. So it is very hard. You see here the single point, and this is the called the holder. According to the operation, this inserts yellow is the change. So mostly, for example, this kind of inserts is used for the roughing and the finishing and the surface for the surface finishing. Also face used for the facing operation, but for the other operation we will see the different tools. So uh, let's talk about some specification of the tool here. Mostly the tools specified according to this language. Okay. Then, and how to analyze this one. This first letter represents the shape of the tool. We will see what kind of shapes could be the tool. For example, here you see this kind of rhombic shape, so it could be the different shapes. This represents the shape. So then is the clearance angle, and then this is the next letter is the represent tolerance. We will see all of them. Then it's the represent hole and chip breakers and so on. There is the difference values here. This you see nose angle, the shape, hole. You see all the parameters is included here. So the nose radius, and here this 3 represents the nose radius. What will the nose radius and so on. So for example, let's start with the shape. If in the letter of the standard of the tool there is a C, shape is the here you see the degree of the diamond, 80 degree of the diamond tool. It is how to read the tool. So there is could be the letter of the T, letter of the S, or letter of the D. If for example letter of the D, tool shape will be like this. If the letter of the R, it will be tool will be rounded and so on. This is the you can take the notes and learn the shape of the tool, how it will be according to the letters. So next is this clearance number. So if it's the 10, the clearance number is the degree is the 0. So this means that is this draft angle. So if if the letter is A, B, C, you will get the draft angle is the corresponding to this angle. So draft angle is let I explain what is the draft angle is this. So for example, here, if the rectangle, if you see this is a rectangle, here the draft angle is a 0. And it will be like this. And the draft angle is this one. So it is what is called the draft angle. So it is the N stands for the draft angle, and there is the corresponding degrees for the draft of the workpiece. So next is the tool. Uh-huh. No, I think it does not matter, but it depends on the type of the operation. How will you choose the? It is not related with the quality. Okay, draft angle. It's it is the angle here in the side of the insert. I mean, for example, if we have this insert, if it is the straight here, draft angle is the 0. If like this, it's a small draft angle. Here angle, and this is the draft angle. Okay, so slight inclination, but you see this is two. Okay. So next is with the tolerance value. So according to the letter M, G, E, A, K, you see that there is several tolerance and several standards for the tool. This is just a specification, some standard for the tool. So you can study these tools and just for the using. When, for example, you want to use the tool for the specific operation, you can take some standards for the tool and just look. It is not necessary just to learn by heart all everything the tool specification. Just you can use the any book when you are using the tool in order to choose the correct type of the tool. So here you see all the standard values. IC values is this one is the diameter of the inside the circle, and this is the thickness, and this is you see the tolerance between the IC the diameter and this angle. So this is the how the values is obtained in the and this is the related values according to the letters and here. Next is the hole diameter, hole the shape here with the other letters. You see, you can make several holes. Just a moment. So standards for the holes here in the middle, in the middle of the insert. So next is these three numbers. So it could be first one. This is the IC level. So it is the this value. So it is the diameter of the this values of the insert. So it could be the ranges from, it could be 3 or 4. If it is the 3, this is the diameter. Sorry, it is the in the inch. Sorry for this. And if it is 4, it is 0.5 the diameter of the this value. This is the thickness value. This is the thickness value. It is also could be the value 3 or 4. In this case, it is in our the example is 3. So thickness is the of our the tool here is the 0.187. So this is the just the two numbers for the thickness. Last one is this value. So it is the here it is some draft angle. I mean the fillets blend here in the corner of the our this system. So 1 2 3 values. In this case in our example is 3. So this is the 0.047. So this is the angle of the here. It could be just this value too small, or it is the in this case it's the biggest value. This is the some specifications of the tool. So as I said before, you can use any standard books while you face such kind of issues in your career. So let's talk about some tools here, which I said before. This standard tool with the here with the rounded edges can be used for the turning operation in the facing operation. So first operation. So mostly you will use this kind of tools. It's the diamond tools with the degree of the 35 and 55. So we have seen that this kind of type of the tool. So it is the shape, represents the shape. It is the, I think that it is the S. This is the S shape. So the diamond tool number is 35 and 55. For the grooving, I don't know, it should be the grooving also in the simulation, but we didn't see it. For the grooving, let's either explain what is the groove is, because we haven't seen in the simulation. For example, if you have the cylindrical element from the side view, and the grooving is the operation to obtain such kind of thing here in the both side also. So it is the call of the grooving. So your tool should be shaped like this in order to obtain. So it will go in this direction firstly in the safe position here above the surface, and goes down until the here in the depth. So in order to obtain groove. So the tool shape is like this in the squared way. So it's not squared but rectangle way to obtain the groove. So with the long the length. So it is the grooving operation. So it is the what we discussed is the boring tool. So in order to enlarge and get higher surface of the existing holes. So it is the movement of the sorry. So movement of the hole. This is the will be the difference. For example, if we have the hole here, the tool goes in this direction. So there is the holder here, and enlarge and make the surface of the existing hole better. Okay, it goes in the reverse direction. So in this way. This is for the threading, which we seen. You see, it has the special point here. So, in order to obtain thread on the outer or inner surface of the cylinder, so you can obtain outer diameter thread or inner diameter. What is the meaning? The outer and inner is for example, you can make the cylinder, and outer is you can take the outer diameter thread, or if you have the hole here, you can make inner thread like this from the both side, from this side also, because it rotates, takes the whole the circumference of the cylinder. So this is the how the threading is obtained. This is the what is the we have seen is a cutoff in order to remove the part at the final in the from the overstock, and remove the workpiece from the spindle. So this is the long edge. It looks like the for the groove workpiece. So we have finished all of the tools of the workpiece. Is everything clear with the tools? There is no any doubts with the standards. Can I go on? Okay, just a moment. Okay, just a moment. So cutting condition is the final topic for today in the lecture. We have seen the cutting condition in the case of the milling, and we defined main two parameters. Is the cutting speed, not the cutting speed. I mean the rotational speed of the spindle, and the feed rate. So in the case of the turning, it is the same. We have the same values. Is the n value is the rotational speed of the spindle, and the feed rate is the speed of the movement of your tool. So in order to remove the workpiece from the surface of the cylindrical element. So what we have discussed, we have the spindle, that is the holes. This is the spindle, that is the holes our the workpiece, this is our the element, and the spindle is rotates. So this rotation is measured by the n value. So unit is the rotation per minute. So the formula for the n is equal to the v cutting speed over the p d. But problem can be arised. So we now use the table. We will see tomorrow how to use the table. It takes into account the material of the workpiece. That takes into account the material of the workpiece. P is a noun. It's a 3.14. But in the case of the turning, this is the problem. What is the D? Since in the case of the milling operation, we use the D as a diameter of the tool, but in the case of the turning, we don't have the diameter. We have the single point edge. So, okay. So, what is the related D? D is related with the diameter of the workpiece. Okay, biggest diameter. For example, overstock diameter means that we have the overstock here, and we have to we want to obtain this diameter, for example, after making some operation. So see, this D stands for this overstock diameter. Okay, not the final diameter. This not final diameter. This stands for this if this overstock diameter, biggest diameter. You will take D as this is the here. Okay, is it clear? What is the D? Because it is important. In the case of the milling, you will take the diameter of the tool. In the case of the turning, you will take the diameter of the workpiece or stock diameter. before the machining diameter. I mean, I will roughly speak. So next value is the feed rate. The feed rate is equal to the feed Z over N. N is what we calculated for the spindle rotation. Feed is the taken from the table, and it relates with the material of the workpiece. Z equal to, in which value? I already explained it. Can you tell me what? Yes, correct. It is equal to the 1, always for the turning machine. So because it is the single point turning machine. So this is the what is the value. Here, sorry, okay. Here it is the N, but I noted it is at a Z. So don't worry. It is, you can note it at the N or Z. It does not matter. Okay, don't confuse. This is in general number of the T's in the case of the turning. So it is equal to the 1. So let's see example. Cylindrical work part with 300 millimeters in long. So this is the 300 is the diameter, and this is the length of the cylindrical part. It's the turned. In the turning machine, cutting conditions that follow the cutting speed, 3.3 meter per second. So it is the V value, but it is, in this case, it is directly given. But in real examples, we will see how to calculate the V value. So, and the feed is 0.35. So we have to calculate just the spindle rotation and feed rate, just simple formulas. Here the same as a milling machine, I put here the 1000. Since the diameter here is given in the millimeter, I converted to the millimeter into the meter in order to obtain the value of the meter, you see, and so I put here the 1000. Is it clear why I put here the 1000? Because millimeter is the 1.1 over the 1000 meters. So here, and it goes to the in the uppercase, so it will take the 1000 multiplied by the V. So I will get 3.5 revolution per second of the spindle rotation. Then feed rate is calculated here. In the case of the Z, in the case of the N, I put here the 1, just multiplication between the N and F. F is the here given here. This is the feed rate of the work system. So that's all for the turning operation. Is the concept is the clear? The main you have to know the what you have to remember, that's the difference between the milling and turning operation, and the cut, as well as the cutting condition, how to calculate the cutting condition in the turning operation, as well as the type of the turning operation, how they operated, the tools, as well as for the theoretical point of view, what you have to do. And also that you have to remember that that Z value, always be careful with the Z value, because from my experience, always students makes several mistakes when they're taking the Z values, and they don't know the what is the Z values and so on. So be careful with this. So if everything is clear, we can make some break, 10 minutes around, in order to before the start. Yes. Mm-hmm. Which slide? Yeah, okay, okay. Just a moment. Okay, are the values computed automatically by? I mean, what kind of values you mean, Leonid? So, other values. Feed rate. Feed rate is for example, when you're making the programming in the NX, for example, you can calculate feed rate by yourself, or you can change the values of the feed rate directly on the machine control unit. You can control the feed rates, speeds, and so on. You can increase the decrease the values after that manually, okay, in the machine control unit. While the it is not when yes, in the programming, that is the it depends on the, as I said, the diameter of the diameter of the tool. So but anyway, you can change it is manual while the making the operation directly on the machine, okay. The machine control unit is needed in order to change the some values. Also, you can change the values of the coordinate system. So the values along the x and y, z, there is values also in the machine control unit. For example, when you work with the one machine, for example, the new machine, it is the surface accuracy will be the good, but with the some periods, it will some periods it will be it will could be some damages and so on, the cause to the shiftment of the values, okay. Some not good surface finish. In this case, you can change the values x and y values by yourself in order to obtain the exact values, okay. For example, when I worked in the, for example, in the GM train company, so as a student, so when I made the practice, I worked in the machining line in of the crankshaft of the engine. You know what is the crankshaft. So in that time, in some periods, we have the manually the changed values of the machine in the some periods, because there is some misalignment during the some periods. So we value we change it the manually. So yes, of course, you can change the spindle speed, feed rate as well by yourself on the machine control unit. You are welcome. So if you don't have any question, okay, please. Okay. Unfortunately, I don't know, since the it was the part of the course to visit the Technopark. Unfortunately, due to the my condition, so I couldn't go to the university. And maybe I will try to organize someone to ask to help and to go to see the. I will try. Okay, maybe someone of my friends. I will ask from him to take you to go to the Technopark to see the processes. Okay, okay, I will try. But for me, I am not post. I cannot. So I will try to ask from my friends. Okay, okay. Can we take the break? Okay, you are welcome. Okay, if you have no any question, let's take the 10 minutes break before the lab. So we will meet in 10 minutes.